We're starting chapter 12, which is talking about how many ways things can happen. You're counting all the different ways things can happen. And this can be actually a very confusing chapter. So just stay with me here. You need to keep up to date if you want to really understand this. And I know you do, because this is also going to be on the MCAs quite a bit. So we're first going to start with stuff that we covered back in 9th grade, if you remember when we colored clown faces and things like that. And so what we're going to start with right now is something called the fundamental counting principle. And you guys might remember this as, I think I called it FCP. And this is when we colored the clown faces. So what happens with the fundamental counting principle is you have events. So if you remember back to the clown faces, we could have 2 colors, so that was one of our events. And so with the fundamental counting principle, you put down a line for the event, and then you put how many choices that you had for each event. So you had 2 colors, and then we had 3 mouths. And so what ended up happening is we take the 2 times the 3, and we have 6 different faces that you could come up with. And then we did another one where we had 2 colors, 3 mouths, and 2 kinds of hair. So we would multiply those out and we would get 12 different faces that we could get. So the idea with the fundamental counting principle is you have all these events, however many events you have a bunch of them. Okay, and then on top you're going to put the number in each event. Okay, and once you have that, once you figured all that out, then you can just multiply them out. All right, so let's think of another one. So okay, so when I was pregnant, we had to come up with names for our kid, right? So we had a couple first names picked out. Let's say that it was, we had Toby Jr. Okay, we had Joel B, which is Toby's dad's name is Joel, and then put B on the end for Toby. And then my vote was I wanted to have the first name be Pi. Okay, then we have our middle name. All right, so our middle name, we could have Frank or Pi. Now, I was really excited about the Pi thing, because think about it, you guys. If you have a first name Pi and a middle name Pi, then you could just say your full name is Pi squared. And then the last name would be Strum. No real choices there. That's the last name of the kid. So to figure out how many different ways we could put that together and how many different names this kid could have, we have 3 names: first name, middle name, and last name. So there's 3 events. And then there's 3 choices for the first name, 2 choices for the second name, and 1 choice for the last name. And so there are 3 times 2 times 1 is 6 different names we could come up with that. All right, I'm also going to be looking on page 702 in your book for another example. We're looking at example 1 in there. And so here's what it says. It says, police use photographs of various facial features to help witnesses identify suspects. One basic identification kit includes 195 hairlines, 99 eyes and eyebrows, 89 noses, 105 mouths, and 74 chins. Again, they have, this must be like on a computer thing or whatever, 195 hairlines, 99 eyes and eyebrows, 89 noses, 105 mouths, and 74 chins and cheeks. So it says a developer of an identification kit claims it can produce billions of different faces. Is that claim correct? So to figure this out, we need to take all of our events, which are all these different things. We have 1, 2, 3, 4, 5. So we have 5 lines. And we place, okay, in the first line that stands for hairlines, there's 195 hairlines. And then there's 99 eyes, and 89 noses, and 105 mouths, and 74 chins and cheeks. So if I multiply all of those together, I will get 13,349,986,650. So again, they claim to have produced billions of different faces. Is that true? It absolutely is true. You have over 13 billion different faces. Now it says, the next problem says a witness can clearly remember the hairline and the eyebrows of a suspect. So they know the hairline. So that's just one, because there's only one possibility. If they know the exact one, that's it. And then they can also identify the eyes and eyebrows. Well, that means that this 99 is now 1 also. So how many different faces can be produced? So now we're narrowing it down quite a bit. And so we have 1 times 89 times 105 times 74. That's 691,530. And although that's a lot, it's still a lot less than over 13 billion. Another example would be talking about license plates. So you can create a license plate. Typically there are 6 spots on a license plate. The first 3 spots are numbers and the last 3 spots are letters. And so if you can repeat, numbers and letters, then we have 10 possibilities for each of the first 3, because there's 10 digits, 0 through 9. And then we have 26 possibilities for each of the last 3. And so that leaves us with 17,576,000 different types of license plates. Now if you cannot repeat, then this changes a little bit. Because if you can't repeat, once you use a letter or a number in the first one, so you had 10 choices for that first slot, that number is no longer available. So now you only have 9 available. That's no longer available, so you just have 8 available. And then for the letters, we've got 26, 25, and 24. So as we multiply all of those together, we're going to have 11,232,000. So that narrows down how many different possibilities we have a little bit more. Okay, now there's all kinds of other ones we can do. We'll just talk about one more. Let's say I want to make a meal, and in that meal for my entree, let's make, we can have potatoes, we can have noodles, and how about salad? Okay, for the meat, we could have, let's see, steak, meatloaf, chicken, and let's see, I'll go with one more, eggs. Alright, and then for dessert, we can have cheesecake, pie, ice cream. What else can we have for dessert? Cookies. Suppose I should have thought about this more before I did it. That's good enough. Okay, so here's the deal. We've got 3 events. We've got the entree, the meat, and the desserts. For our entree, we have 3 possibilities. For the meat, we have 4 possibilities, and for dessert, we have 4 possibilities. So as we multiply that out, we're going to have 48 different meals that we could make with that. Okay, the last thing I want to talk to you about is factorial. Now you might remember factorial from before, but if I wanted, let's say we have 5 people running in a race. So the events are getting first place, second place, third place, fourth place, fifth place. So we have those 5 people running. Here's person 1 running, and person 2 running, and person 3, person 4, and person 5. Okay, so we have 5 people. They're running around, running, okay? Here's the finish line. Now, one person is going to cross the finish line first, okay? So there's 5 people here that could possibly cross the finish line. So for first place, we have 5 choices. Now, that person crossed the finish line. So now we have second place. There are 4 people that could get second place. Okay, now that person crossed the finish line. So now we have 3 people that could get third place. That person crossed the finish line, so now we have 2 people left for fourth place. That person crossed the finish line, and now we just have that one last guy for last place. So this right here, when you take 5 and you multiply it times every number below it all the way down to 1, we call that 5 factorial. And if you remember, we use an exclamation point to stand for that. So whenever you see an exclamation point, we're saying that it's a factorial, and so you're going to take every number below it and multiply it out. And let's see, 6, 30, 120. So there's 120 ways they could finish this race. All right. Let's see here. Let's say you have a shelf. and you want to put some cups on that shelf. Okay, so you're trying to figure out what cups can go on the shelf and in what order. Maybe they're decorative, so they look all different. Okay, and so you have 4 cups that you want to put on the shelf. Well, the ways you can arrange them is going to be 4 factorial, because in the first spot you have 4, in the second spot you have 3 options, in the third spot you have 2 options, in the fourth spot you have 1 option left. And so 4 factorial is 24 ways that that can happen. All right, one last example. Let's say you're at the movie theater and there's 6 of you, 6 friends going to the movie theater, and they want to sit in a row, one long row. And so you're trying to figure out how many ways can that happen. Well, if there's 6 seats and there's 6 people, there's going to be 6 factorial ways that can happen. 6 people could sit in that first spot. Once someone sat down, we have 5 people left. Once someone sat down, we have 4 left, and then 3 left, 2 left, and 1 left. So 6 factorial is going to be all of those multiplied together. Let's see, 120, I have no idea. 720, I think. I could be wrong. I probably am wrong. But anyway, I think it's 720. Now, with this factorial business, one thing you need to remember is that order matters. Okay, this would not work if order didn't matter. If we didn't care what order these people sat in, there's one way you can all sit down then. You all sit down. So order matters. Remember that. If order doesn't matter, we don't want to use factorial.